let's get started. So good morning, everyone, or good afternoon, good evening, everyone. This is Yu. I'm going to present this symposium workshop with Jennifer and Sylvie. So this workshop is, we're going to talk about the challenges and solutions to examining tutor data. So we're going to reflect on the QE data challenge that was happening at the end of April. So welcome to our session. So before we get deep into the discussion of the data challenge, I'm curious about whether folks have been working with social media data or what kind of challenge you have been encountered. So Kate, sorry for calling you out, but have you ever worked with any social media data, and how was your experience with it?
It's no problem. I'm working with Reddit data. It's super cool. It's super exciting. It's also kind of a nightmare because of its hierarchical and threaded nature. I'm still working through that. I think it's a really cool opportunity, and I am not even close to making full advantage of it, which is a good part of the reason I'm here to see how you all handle things.
Yeah, cool. May I ask what is the topic of your project?
Yeah, for sure. So I'm scraping data from the subreddit on depression, specifically how people talk about side effects of antidepressants and the kinds of support that they give each other.
Yeah, that's pretty cool. Thank you, Kate. And I also saw another folk here, Carl. Hi, Carl. Welcome to the session.
Hello.
All right. We just talked a little bit about experience working with social media. Feel free to share your experience, or feel free to post in the chat box, whichever you want, Carl. All right. So that's good to know. I hope this workshop would be helpful for you guys to deal with the social media data in the future. And now let's get started. Just a little overview of the data challenge. So the challenge was week-long. We had participants and collaborators all over the world. We hosted the data challenge during pandemic, and we're trying to help the world understand how and why people react to this crisis in which way, in a certain way. And we also analyze people's response over time and between places in the world. So I had researchers working collaboratively during the data challenge. They came from academia, they came from industry with interest in anthropology, entrepreneurship, learning sciences, data sciences, etc. Some teams explored something about the politics. They explored the COVID-19 related content of tweets from Donald Trump, the previous president of the United States, and the Center for Disease Control CDC from January to April in 2020. And some teams compared the discourse related to COVID-19 directed at selected Republican and Democrat politicians after the announcement of the economic stimuli package. Some teams collected data about remote learning. They invested how various stakeholders in education were contributing to the discourse and responding to this massive shift in school structures. Or just some general reviewing about the tweets of the public at 2 time points in April and in May to see what was the most challenging themes appear to be and the connection between them. So most of the team went through the stages like collecting data, coding, and modeling. In the coming sessions, Jennifer, Sylvie, and I will introduce some common challenges across teams and possible solutions to them. So the first challenge is to get data. There are so many data scraping tools. However, most of them need us to pay for service, which is not a good news, especially for graduate students. Or you could write Python scripts, use the package called Beautiful Soup, but it requires some programming skills. So the solution that we found is to use the open sources package from GitHub called Hydrator. It allows the user to extract data from the public data sets provided by IEEE. We have several teams use this method, and it doesn't need programming at all, and it's very convenient to get data that you can play with. Another issue is the abundance of data, which is not unique to social media data. We know that qualitative data analysis also face this challenge. In order to find some interesting story, we always need to go through way more data than we expected. A metaphor is that 40 gallons of soup can only produce 1 gallon of syrup. However, this poses some practical challenge. For example, some web tool cannot handle big data, or the calculation is taking way too long time. So the solution by some team is to downsampling the data and downsampling the whole population into a smaller set. For example, some of them filter the data sets down to the most relevant components, like the major characters or major rows in the data set. Or they could limit the scope of the tweet to a particular hour or for a particular user, or exclude some replies and retweets and only code for the original tweets. So those are some of the solutions addressing the abundance of data. And Kate, I know there could be some issue about the abundance of data in your Reddit dataset. So we're happy to hear more about it and how you address them. All right, now I'm going to hand over to my colleague, Jennifer. She will talk about coding and the challenges in coding.
Thank you. Yeah, so when we started going through the challenges with coding, we realized that many of the issues that we have with coding come back to the fact that the language of social media is so different from the language that we otherwise would encounter with how people talk. It's not very often that people are walking down the street and you hear somebody actually say #trending. People usually don't speak in acronyms. And even if they were to, if you were part of that conversation, you would know exactly what they meant. Some of the acronyms, these ones are all fairly popular: IRL, for the win, laughing out loud. People know what those mean, but when you start to look at different subsets of a population, or when a new abbreviation comes out, I have some younger siblings, and so there are times where they throw something into a text to me and I'm like, I have no idea what you just said. In these short utterances, it's also incredibly hard to tell when people are being sincere and when they're being sarcastic. So you could have somebody in our tweets that were all about COVID. Somebody could post a tweet that says, "Just got back from the grocery store, most harrowing experience of my life, #COVID." Now, are they actually genuinely concerned for their safety? Because we're in the middle of a pandemic and that is a fairly reasonable thing? Or are they being sarcastic? And without a greater context of conversation, knowing that person, knowing how they're trying to draw their friends into the conversation, we can't make that assumption. It's incredibly challenging when you're looking at just one single utterance. Specific to working in encoder, which is how several of our teams were coding their data, there are issues with spelling on social media. Twitter doesn't actually let you edit your tweets. So if you misspell something, it's out there. So how do you catch every way that people are potentially referencing something. And if you are going to miss things, like, is there a way to capture like the most common ones? The other piece is like similar phrasing. So when you're working with a really short amount of words, we had some challenges between, this is an example of our regex that we were trying to capture when they were closing down airports. And a lot of people were referencing they were closing down flights. Well, there's a difference between I'm close to missing my flight versus I'm closing down flights at the airport. But both of those would be flagged in that case, just because close could be used in different ways. Same thing, sometimes things are capitalized or punctuated in weird ways that actually have meaning, and trying to capture those in social media discourse can be challenging. But we did have some solutions, if you want to swap over. One of the things that was incredibly useful, as Yeyu said, is first of all, you're taking this large data set and you're pulling a sample. But there were so many nuances that kept coming up and kept reappearing as we would try to code the data that we really iterated through it quite frequently. In order to combat that, we found it incredibly useful to have not only the sample and not actually touch your sample until you've played with a playground data set that's like a separate sample. So here you can see that we have like all of your possible relevant data, and you actually pull a sample of that into encoder, and you pull a separate sample into just a playground area. And with that playground data, you can actually go through and look not only for how would we code this, but you can utilize things like nearest neighbor algorithms to help you identify what other things might be useful when trying to identify that concept. You can also do just searches without looking at your actual training and test data to double check your assumptions of how you think something is going to get flagged in your data, or how you think a concept is playing out. And it was really useful to be able to do that and check our assumptions, because every time we had something that we thought we would be able to code in a certain way, it was almost guaranteed that there would be something unexpected that we didn't consider. Often that also included things that were like spamming tweets or things that were trying to like push into the COVID conversation that weren't necessarily there. So this was a way for us to segment our data into different buckets so that we could really hone our own coding skills. And I'm going to turn it over to Sylvie to talk about what do you do with that data once it's actually coded.
Yeah, the short answer is, well, I don't know. But thank you. Yeah, you be my hands. Thank you so much. So let me be incredibly philosophical for just a moment. So when we embark on a research question, we take a small section of the world that's messy and complicated, and we don't really understand what it is, and it's really hard to kind of hone down on what we want to actually look at. And then click. And then even if we do hone down on that and say, okay, this is the section of the world we want to look at, it's really hard to segment that section, because if you think of codes within this picture that we see here, kind of littered all around the entire square that we began with, those sections that we designate as meaningful segments might influence our results to a huge extent. And that's kind of a hard question to deal with, no matter what framework you're working with. Click and click again. Thank you. So in terms of Twitter data, we were, actually, can you click again, Yeyu, please? Thank you. We were confronted with the fact that segmentation in QE, dividing your data up into meaningful segments or parts involves designating an utterance. So the lowest level of segmentation, this is where coding occurs. And then you need to also designate a higher level of segmentation, or the highest level of segmentation, which can be called a source, or you can call it a unit. In any case, that's where sets of utterances are aggregated. And then you might want to have mid-level segmentation as well. And this is something that Kate will have a lot to add, I think, where you want to decide on these levels of, which utterance can be connected to another utterance. And that's where the co-occurrence of codes happens. So that's actually a very important decision that you need to kind of think about and justify for yourself. And it might not be uniform throughout the whole project. You might want to change that decision as you go along. So in terms of Twitter data, well, we can think of maybe a post and just the direct replies to that post. Thank you, Yeyu, being one stanza, or we can think of that as being one utterance as well. So it depends on how we want to see segmentation in our data. Click again, please. We can also consider the entire thread an utterance, but we can consider that as a stanza as well. In fact, we can even move higher and consider that the source that the whole source that we will be coding. And if you click again, Yeyu, there's another issue where you might want to designate even closer connectivity between two utterances or two stanzas. So you might want to have different levels of mid-level segmentation, if that makes sense. Please click again and again. Right. So as we go on in thinking about how to segment our data, one of the main questions that we need to ask, click again, please, is what we want to see the units for, what we want to see the networks for. So what will be the unit in our epistemic network analysis? So we can think of one thread as a unit, but we can also think of all threads coming from one data provider, for example, David Schaefer in this case, or in our case from the challenge, it was Donald Trump and the CDC, but you can think of data providers in a very multi-leveled way as well. So how do you decide on which of these things to group and how? And that's an important question, not only for segmentation when you're still working with your data, but also when you start thinking about how you will use the web tool itself. And the web tool, so ENA operationalizes relational context in two ways mainly, which is conversation. So how groups of utterance, so which groups of utterances should be considered as connected, that's conversation. And also click again, please, Yeyu, stanza window. So how stanza window designates how connection structures are computed. Please click again. And in that respect, we had three options in front of us. Click. Click. We had a moving stanza window as an option, which computes connection structure, the connection structure of each line in a conversation relative to every line before it, but within a window. Here you see it illustrated with a window of 4 lines. And then click. Another option was an infinite stanza window, which is the same thing as I just described, but there's no limit as to how many utterances come before it, except for the conversation itself. So it goes on throughout the whole conversation and aggregates co-occurrences as such. And then our last option was the whole conversation window, which computes co-occurrences in quite a different way, because it looks at in a given conversation all the lines from one unit and just checks whether or not a code co-occurred or not. And it's a binary thing, so it's either there or it's not. And many of us chose to use the moving stanza window. I think one of us used the infinite stanza window, and I think another group used the whole conversation window. So basically, we all made different choices here. And for conversation, if you designated, for example, tweets occurring on the same day as a conversation, which is a legitimate choice, then you run into complications such as, how do I designate one day? Because we're talking about international data, right? So where do I draw that line? Again, this is a matter of, parsing and segmenting your own data. Where do I draw that line where one day began and another day ended? And for, whichever, so for example, you chose the infinite stanza window and you chose conversation to be, for example, a day or a month. Are those tweets, are those threads connected even in that sense? Does it make sense to use an infinite stanza window and say that everything is potentially connected in that group or not? So these were some of the issues that we encountered, and we all made different decisions and generated our results from that. So now I'd like to ask you to go to our final slide. And here we just had some questions based on the things that we talked about so far in collecting data, in coding it, segmenting it, and then creating the models. And we would like to turn it to you guys. You're obviously here because you have some experience and or frustration and or inspiration working with this kind of data. We'd love to talk to you about anything that you felt was inspiring or you had trouble with. Actually, I think I'm just going to call on Kate because she she has expressed some inspiration and or troubles, and we'd love to hear about your data, so Reddit data.
Honestly, I didn't start because I have so many questions. I don't know where to start.
Oh, okay.
I will start at the top of my list. How did you handle spelling? So I'm collecting huge amounts of data based on generic names and brand names of drugs. I know that many of these are misspelled, but they're misspelled in so many different ways. Do I really have to go through my data and manually make a list of that? That sounds awful.
How many ways do you think people spelled hydroxychloroquine?
Right? So what do you do?
So that was one of our issues in Encoder for sure. One of the things that we did was we looked at the likelihood, and this is where that playground data set came in really helpful. First of all, if people were talking about COVID, they weren't talking about some other hydroxy drug, right? So we were able to kind of take the chunks that we were fairly certain that people would spell correctly, and we used in regular expressions, you can use parts of a word, like a word that begins with this, or that is, this part is in the middle. And so we had hydroxy as part of a way to code. And then we also had chlor just by itself. And usually chlor would occur with something else that indicated that it was talking about a drug. And so we kind of segmented the actual drug names to be able to do that. And for us, it did actually work out pretty well.
Yeah, that sounds good. There are definitely parts of drug names that I can repeat.
Yeah, I saw Andrew and both Andrew and David raise their hands. I first saw Andrew, so how about Andrew, you share a little bit, then we go to David.
Thanks, guys. This was really interesting. I actually wanted to ask a little bit about, Sylvia, you had mentioned that, each of you kind of took a different approach to setting up models. And I'm curious how much of a difference it made. Because one of the things I always wonder about social media is that it's so you know, each post is so, at least in Twitter, each post is very short, but you also get so much of it. I wonder how much do the differences just kind of come out in the wash, at least at the sort of higher level, or did you see really big differences depending on how you structured the models?
Yeah, we didn't work with the same data, so it would have been super interesting to compare those different models with using the same data. So I can't really answer that objectively or at all. but I do want to say that it was fascinating hearing, because we actually discussed this, you know, when we were preparing the symposium description. And I was really interested to hear why people made those choices. You know, that there was a group that used whole conversation, for example, and I was incredibly interested to hear why would you make that choice for this data? And so I think we're presently in a state where it's just interesting to hear the logic behind certain decisions. And I don't think we could come up with a way to prescribe, you know, like a good way to do this right now, because they all made sense, but also none of them did completely. So I think we're just exploring the possibilities right now. If that answered your question.
Yeah, thanks. I was just curious. I didn't realize you guys were all working on different data, so that makes it a little harder. But
yeah,
I mean, I just, you know, I'll just say that I think this kind of data is incredibly hard to work with, as you guys, for all the reasons you guys are pointing out. And so I'm sort of curious to see when people can make it work. I'm curious sort of how they do it, or what they're able to get.
Yeah, I do want to add one thought though, which I think for me is something dangerous, but also something that I tend to do. We began with the infinite stanza window model, and we got the models that we actually published in the poster. And the first time we looked at it, we were like, that's it. And then we didn't even try anything else, right? So it was so, yeah, that's exactly what was happening. Trump was doing this and CDC was doing that, and the models reflect that. And we didn't actually go the extra mile to try other parameters and to, you know, I mean, we looked at the data and kind of went through this interpretive loop, but we didn't look at the other versions that we could have produced. And I think that's something that could be dangerous if you find a model that works like right off the bat.
We were one of the groups that used whole conversation, which for us was it's a bit misleading because our conversation size was at the level of one tweet. So it was really the same as having a one line window. The reasoning behind it was because we had so many different authors, there was no way to argue that they could have potentially seen each other's tweets, or that they were even truly part of the same conversation. Because we had people from different countries that were in general tweeting about the same topic, but it could have been more relevant to local or national politics. And we were more focused on like, how were people referring to the political parties in relation to these issues. So for us, it felt more reasonable to stay with the smallest unit size that we could potentially have for our conversation.
If you're looking at, you know, one tweet as a conversation, it doesn't even make sense to use a moving stanza window or something like that, right? Is that part of the reasoning? Yeah. David?
Yeah, sure. I'm reflecting on what you guys are saying, and it seems like there's sort of multiple overlapping layers of problems here. I mean, one of them is, at least if you can correct me, or Andrew can correct me, but I think as of April last year, we didn't really have a very robust threaded version of ENA, right? So, I mean, one of the problems here is that the underlying syntactics of Twitter, right, don't match the syntactics of regular conversation, right? You have this, it's threaded. And that's sort of a problem that we've solved. Like we can handle threaded data such that you could think about conversations as being both replies and retweets, and like it can, you know, ENA, there's a version of ENA that actually understands that syntax. Now you still would have questions to ask about, you still have questions to ask about, you know, exactly what parameters you wanted to impose on that. If I have a thread, how many lines back in the, how many tweets back in the thread constitute the ground that I'm responding to? Is it an infinite stanza window? And so on, right? My suspicion is that the tweets are short, that these threads are short enough that you probably actually would just use I would just use an infinite stanza window in most cases. But so that's partly, you know, and partly the reason that we have threaded ENA is precisely that people started working with, it was actually Twitter data that prompted it for Twitter and Reddit. And we said, oh, well, yes, that's really hard to accommodate within the kind of data structures that we currently have. Then there's a second problem, which is the sort of semantic side, which is the coding, right? And that, it seems like there's a couple of issues. One is broadly this kind of issue of spelling and abbreviations, and the way in which Twitter language is not, we don't think of it in exactly the same way as we think of regular language. And then there's this contextual question, right? Jennifer was sort of making this argument that there are a lot of times where, in part because tweets are so brief, it's really hard to interpret just one tweet without having any context. Like, in a sense, tweets, especially replies, are completely embedded in the context, even more so than in many cases ordinarily discursive talk. So each of those, I think, of course, is a conceptual challenge, but I think that one way to look at these is similarly, they could be challenges for actually just changing the tools to understand the syntactics and semantics of this domain better. So, for example, like in terms of the misspellings, right? There's the concept of Levenshtein distance, which, for those of you who don't know, is the number of characters that you'd have to swap in order to turn one word into another, which is a very typical way of detecting misspellings. Right, so there are ways of augmenting like what the regex is doing to try and account for things like, you know, spelling differences and errors, typos, those kinds of things. And then the other piece is, and this is a known problem from back at the dawn of time, which is you know, derived coding to account for context. Right now, the coding tools only know about the one piece of data that you're looking at, and there isn't any good way for them to integrate across multiple pieces of data. There's some conceptual issues in that, but partly it's just like we haven't actually built the tool that does that, right? That lets you code the data and then line up those code encodings and make inferences about the meaning based not just on what I'm seeing here, but on other things that I've coded for elsewhere in the data. So it seems to me that like I take this discussion as really positive. Not that you were suggesting it's negative, but like I see this less in terms of its constraints than in terms of its opportunities.
Yeah.
I think this really illustrates well the way in which one of the things that this community has been trying to do is take tools, put them in conversation with data, and when the tools are wanting, then to take that as an opportunity to say, okay, so now we need to think more deeply, like in the case of syntactics, about like what how communication is actually organized. And we have to make it so that the models can actually understand that better, rather than trying to kind of cram one thing into another. We actually have to recognize that the problem that we're looking at requires either different tools or more tools. You know, Sylvia's rock is a great example of that, right? You say like, look, there are situations where we really want to be able to do coding in this open way. How is it that we can, what rock understands the way that you wanted to code, Sylvia, in a way that encoder doesn't? And it's because it's that encounter with the sort of the data. So I mean, I've just thrown some ideas out, but I guess my sort of question back to the panel is kind of a provocation. Like, what do you want, rather than like, what do you want the tool to be able to do? And do you have any ideas about how it could do that? That would make this work easier, if you see what I mean.
Like a wish list for the tool?
Yeah, well, I'm thinking less in terms of the specific existing tools, although obviously if some extension of the existing tools would be helpful. But like, what tools do you want in your kit to be able to solve this, to be able to make this data as kind of well accommodated as classroom discourse data is in the existing toolkit, right? What does it have to do? And that doesn't mean that, like, I'm not asking like, so at Madison, what should we do for you? I'm saying like, what does the community need to start thinking about in order to address this question?
I'll start with like a very small, short idea, but it's not very clear in my head how we could even address that right now. But this idea of being able to address the threadedness or the nestedness of this kind of data in a fairly easy way, just to be able to switch your perspective on what's connected, you know, what groups of utterances I consider connected. I think that's a key thing here, because I think there's two ways of looking at this kind of data. One, you can either wish for an analyze button, you know, that you just click on and then it's done, right? that's kind of wishful thinking on one end, maybe for the slightly more lazy researcher or someone who's in a hurry. But then the other the other end of the spectrum is someone who says, I have so many clear ideas of how this is interconnected, and I want to be able to see that at the same time with the tool that I'm using, or be able to switch among those, you know, different systems that I have already in my mind as I go through the interpretive process.
What sort of, I guess, what sort of systems are we talking about? You just dealt with the data. Like, what were the things that you wanted to be able to explore more easily? I mean, like, okay, so the threadedness we've talked about, right? But so there's, what other syntactics were you interested in being able to model?
Well, I'm not sure that this is presently inaccessible. I'm just thinking about the complexity of coding that it comes with. And I'm thinking of, you know, we looked at Donald Trump versus CDC. So we could segment our data from Trump only based on time, based on topic, based on the number of, you know, responses or the engagement that it got. So all of these are kind of attributes of the same data, right? But within the text, there might be topic-wise, there might be connections that I would want to look at. And so that would mean a different grouping of utterances every single time I want to switch the system that I want to look at.
Okay.
It almost,
Yeah,
go ahead, David.
No, please go ahead.
I was just going to say, it almost sounds more like a data formatting issue to be playful with the way that we're formatting data. So that was one of the things that our team did before we even entered any tools was we created some arbitrary codes and groupings based on more simple like metadata about the tweet itself. So things like you're saying dates and country, even I think at one point we had like what state they were from. But also things like just Republican versus Democrat balanced. Those aren't things that the tweet came with, but it was a simple word search that then we just assigned it in, we were using Python to do it. But just creating some of those different, like just adding more metadata onto your data table allows you that flexibility to swap your model around. Does that sound like what you're referring to?
Not quite, because it's not a matter of metadata or attributes. It's a matter of segmentation. So I would want to have various levels of mid-level segmentation, which I could then decide on which grouping I'd want to see in what way in the network. So it's not the grouping variables, it's how you segment the data itself. I mean, the utterances, how you group them together.
So can I just try and revoice that back so I make sure that I'm understanding it correctly? So one of the things that happens now in both the kind of big D discourse of quantitative ethnography, that is the way people, conceptualize things, and in the way the tools are implemented, there's a choice that's made relatively early on as to what constitutes a line of data. And once you've done that, each of those pieces of data gets, your choices are only to think about their ordering. We're working on tools to think about their temporality, right? It's on their time-based relationship. And conversations. And there isn't a way, so there isn't a way to decide how you would want to group lines together for some other purpose. And so just as a thought experiment, right? The people often, think about like interview data, right? And should the line be each sentence, or should the line be the whole answer to one question in the interview, right? And there isn't, whichever choice you make, there are then some things that are become difficult to do in the tool. So for example, right, I'm just trying to make sure I get all this, right? So if I segment by sentences, then there's no way to have a moving stanza window that looks back 3 answers, right? If I do question answer, if I segment by the answers to each question, the interview has 10 answers, and what I want to do is have the stuff in answer 2 in the same moving window with the stuff in answer 1, I can do that, right? But now I can't look at the sentences. If I look at the sentences, now there's no way for the system to know that what I want to do is include all of the sentences that were associated with the last answer. That is the sort of the moving stanza window and the lines are kind of locked together in a way that limits your flexibility. That's sort of a translation of what it is you're trying to get at.
I think it's the tip of the iceberg. I think there are a lot of very specific issues that come up with no matter what you're working with, interview data or Twitter data. But I did want to hand it over to Kate because she had specific problems with segmentation. Maybe we can just look at an example that she had.
Yeah, I actually was gonna ask that question next, so thank you. So one thing that's really common is you have a post, and it's an interesting, good post, and you have a bunch of top level replies, and you have replies to those top level replies. And my inclination is to essentially step through the tree individually. The problem is then you have posts and top level comments that are overrepresented, which feels uncomfortable to me, but I can't quite put my finger on why. And I have a hard time thinking through the advantages and disadvantages of doing that, or how else I might capture what I really want. Because what I really want is the interactions between people. Like, I really need to be able to tell the difference between different levels of comments and who said them.
Can you say more about why you need to know that? I'm not suggesting that you shouldn't need to know it. I don't know. I'm not sure I understand what the use case is.
Sure. So my central question is, how do users support each other in these conversations? The idea being the kinds of support that you get at the doctor's office and the questions you have and the things you want may not be what the doctor can or would know to provide. So a lot of people have, for example, the question, I'm having this side effect. Does anybody else have this? And a doctor's not usually going to tell you, 60% of other people have this. And even if they do, that's not really what it sounds like people want. What it sounds like people want are personal experiences and vignettes, for example. So I need to know, for which drugs do people most want to hear other people's experience? For which drugs do people most want validation versus information about what are possible side effects? Does that help?
Yeah. Yeah, I don't, I mean, you and I'd be happy to chat, but yeah, I don't want to take up the what little time's left in the session to talk too specifically about it. But that seems like it's a solvable. Once you have a threaded model, that seems like it's a solvable problem. Like some clever coding could get around that. It's not it's a good and important question and issue. It's not quite the same thing that Sylvia was talking about with the segmentation, though, I think. Right.
I agree with that. I think I do have a version of what Sylvie was talking about, though, because some of my codes, you need a bigger context. So one important code is somebody saying, yes, I've also had that side effect. So you need to go up in the hierarchy a couple levels. But there are other codes where I just need to know within one comment or one post, does it mention a specific drug and a specific side effect? And I don't want to go back up in the hierarchy because I want to know if one person has both.
Yeah. Okay. Well, I mean, again, so this is a really good example of derived coding, which I think too few people use. But like, imagine that you had coded every post with the drug and side effect and all the things that are going to be your key codes, right? And the problem that you just described, right, is that you have a deictic marker. You have somebody saying, I have that, right? And you don't know what the that is from just the context of the post, right? But so now imagine, and forget for a moment about the way you would do this technologically, right? But imagine that you were able to shift all the data so that every post was lined up with the previous post, right? And so when somebody said that, you'd have right there associated what the codes were in the previous post. That's sort of the idea of derived coding. And so now you can say, you're saying essentially, if this post is deictic, if it's pointing, and that, then whatever codes in that post belong on this post. And now that may not solve this problem exactly, but once you introduce that ability to have a kind of primary coding where you're talking about what's actually in the data right there in front of you, however it's been segmented, and then you can, at the code level, ask questions about what's, things that are going on elsewhere, and use that to make a determination about the code. That really opens up the possibility for solving problems like that. and lots of other problems too, right? I mean, you can easily imagine places where there's other kinds of context that you need. Deictic markers are easy because literally somebody's saying, I'm talking about that other thing, but there are other more complicated examples.
Yeah, that's exactly what I want. So it sounds like maybe we should talk offline about how exactly
Yeah.
to do that.
Yeah, I think that one's a not the tool doesn't facilitate that right now, but I think that's a sort of a more solvable problem. I suspect that doesn't satisfy Sylvie though, knowing her.
But that's a good thing, because I'm still motivated to, you know, phrase what exactly I wanted to say and to explore all the vast tools and features that are available. Should we wrap up the session? Yeyu, did you want to close it off for us?
Thanks, Sylvie. I think you can go ahead and close this session.
Okay, I got the torch handed back to me. Thank you guys for coming. It was really fun to talk about all of this. I think these are issues that not only pertain to the actual data that we worked with and social media data in general, but we also touched on some things that are not specific to social media data and just challenges and things that we encounter no matter what type of data that we use. And I always enjoy those conversations as well. So thank you for coming, and we will see you around.